the Weapons Collective Edge. Welcome to the Weapons Collective Edge. Today what I'm going to do is I am going to test out a preferred steel that I enjoy. I like 5160. So 5160 is an alloy steel that I cut 6 pieces out of this. They're all going to be the same size. They are all going to be annealed and normalized, and then I'm going to quench them. And so I'm going to quench them in water. Parks 50 right there, and regular canola oil. So with those, after I quench these, I'm going to test the hardness after it's been quenched. So it'll just be straight quenched, and then I'm going to test each one after it has been tempered. So the tempering on it, and decide on, it'll soften a little bit but make it a little bit stronger. And then after that, I am going to put it in a mechanism I tried to make here. We see it here. This is just a PVC tube, 2 foot long. It's got it so that, if I show you here, I can mount the steel here, and I'm going to put a 10-pound weight down the tube, and it'll hit the piece, and we'll see if it breaks, and then we'll analyze it a little bit more. So that's the plan, and we'll go on to the heat treat part. We'll see you in a bit. We did a set of normalizing first, and now we're going to do it in anneal. So I'll show you what's in there. We got our 6 bars in there, and we're going to let those finish heating up. They look pretty good inside there. Going to turn it off. We'll let that anneal, cooling it all the way down until it's room temperature, and then they will be annealed. And then from there we'll do some heat treat. So there's our annealing and normalizing before. Normalizing, put it in, get it up full hot, put it out, let it cool on the table, put it back in, and then let this cool down inside the furnace so that it slow cools. And then we'll proceed to do some heat treat. So I annealed the 5160, and we're going to Rockwell test it right here. We're looking at about 36 Rockwell right now. So that's soft enough to machine, and then we'll harden it up and see what it gets to. Quenching in canola oil. Quench in water now. Gonna quench in Parks 50 quenching agent. Second one. Check this one with a magnet to make sure. There we are. Quenched in water. Looking at about 56 Rockwell. Quenched in canola, looks like we got 54 Rockwell. Did the Parks 50 quench with the 5160, we're looking at around 58, 59 Rockwell as quenched. Doing 3 sets of tempering at
450 degrees, 1 hour apiece. And that's on the water quenched and the canola oil quenched. So we're going to test the Rockwell hardness after those are done in the tempering furnace. 375 tempering for the Parks 50 quench. You see there we got 375. And we'll give that one good temper for 1 hour. Parks 50 after tempering at 375 in the toaster oven. I got a Rockwell of about 56. So that would be our end result on the Parks 50. So this is an overview of what we did. So again, these were water, these were canola, and these were Parks 50. So Parks 50 is a preferred quenching oil that has a 7 to 9 second time for reducing the heat in the steel to get you the right hardness. So this is the data, if we'll be able to read this. The as quenched water was 58, canola as quenched was 54, and Parks 50 as quenched was 58. The water warped, the canola oil didn't, and the Parks, it might have warped a little bit, not as much as the water. Water is not a preferred method for this particular steel. 5160 will crack or flex too much and you'll have problems. But I did it anyways just so we can analyze the differences. We had afterwards, I tempered it. I did do these slightly different, but water I did at 450 and that ended up being 52, and I had 3 cycles of 1 hour. The canola tempered at 450 came out to be 50 Rockwell, 3 cycles in 1 hour. And I reduced everything to more reasonable numbers. For the Parks 50, I did 375, and that came out to be 56, which would be more of a preferred hardness for any kind of knife or a machete. It's still a little bit low if you want a real hard knife to keep a sharper edge. And I did 1 cycle on that for 1 hour. But we're going to go back and we're going to test to see how all 3 of these break or don't break, hopefully, and we'll come up with that. Okay, here's our first test. This is the water as quenched without any tempering. Here we go. And we broke. So I will show you the grain structure on that. Try to get a couple camera angles so we can see it. So I anticipated that one snapping off, and that's what it did. So there we go. So that was the water as quenched, which ended up being a 58 Rockwell, and it snapped. So we'll go on and do the next. This is going to be the water. This is tempered 3 times. We'll see what happens here. Again, we got it snapped. There's the grain structure on that one. This is water. This was tempered 3 times at 450, and that ended up being a 52 Rockwell. This is going to be canola oil as quenched. Snapped off. And that is the grain structure on the canola oil as quenched. This is canola oil tempered. Let's see how this goes. 2 pound and 10 pound weight. That one did not break. Get that one out of there. And we'll give it, take a look at it. So this was canola oil. It ended up being 50 Rockwell. And there is our 50 Rockwell. And that was canola oil. This is the Parks 50 as quenched. There we go. Snapped off. I will show you the
grain structure on that one. So that's the Parks 50 as quenched, no tempering. That's how that one snapped off. And we'll do our last one, which is going to be our Parks 50 with the one set of tempering at 375, which brought it down to 56 Rockwell. So this is the Parks 50 that is 56 Rockwell, and that is tempered at 375 for 1 hour. Here we go. That did not break. Let me get that out and we will show you that one. So, this is our Parks 50. Got a bend to it, but is not shattered. That was final temper on that was 56 Rockwell. That was a 1 cycle at 375. So pretty rudimentary testing here. But like I say, both of our waters, this is 58 Rockwell, this is 52, as quenched and tempered, both shattered. This was being 52 Rockwell. We had our oil, which was canola. Canola, this was 54, as quenched, this was 50, tempered 3 times. This one is not broken. This one was broken. And then we had our Parks 50, which again is our preferred quenching medium. There's a 58 as hardened and 56 tempered. So the success story was the Parks 50 had a higher hardening range of 56 that succeeded in not breaking and actually less deformation. The oil that was our canola succeeded with a 50 Rockwell, and it bent a little bit more than the Parks did. But 1, you got oil was a better quench. 2, on this one, at that kind of Rockwell hardness, you're not going to have probably as easily a chance of breaking. But because of the preferred quenching style, I believe our 56 Rockwell, which this one was 52, this one was 54, those were both less than the 56 and both shattered. So in ending, I do believe that we got a little bit of testing on how each quench style was going to achieve a result of me testing out basically its toughness and seeing if a 10-pound weight smacked into it at the same distance every time for each testing would see what would happen. From what we can see, that the oil seems to be obviously the better quenching medium. Water is just, it's too intense for that particular 5160. And both of them shattered, so even though I tempered the one really well, it's still shattered. As far as the canola oil, it's a little bit too low on the hardness scale to be decent for what you want to make out of it. And it didn't even succeed either on the as quenched. It also broke. So, and then the 50 Rockwell was probably what saved it, and because it didn't quench nearly as fast, it would have the tempering made it successful also. Then we get to the Parks 50, which again was the more preferred style of what you want to do for quenching, and that was succeeded, as we saw, when you did temper it. A lower tempering, which means I can get a higher RC, and it's 56. That was almost as high as the top, even as quenched. As quenched highest was between 58 and 59, so I only lowered it about 3 points, and it still succeeded and did not break. So very rudimentary test. It's not scientific or nothing, but at least it gave me what I could do in a forge that's just propane, going by a magnet testing to see if it's up to the proper heat, and anything special, no special furnaces, not really a controlled environment. So I just wanted to give that. 5160 is my preferred steel. I'll put up some data on that, and that's what I wanted to test. So I think it came out successful. I like what my results came out. I will catch you later, and I'll see you the next video.